I'd like to introduce my panel. You know, we got 4 people here with a wealth of experience from supply chains through to carbon trading. We've got an MEP from government and someone that's been in this space for many years and is the founder of Bitcoin.com. I thought what I would do first is allow everyone to just give a quick introduction to themselves, and then we can start with discussing the space.
I'm Max. My background is I used to be in finance, and part of what I was doing was in carbon credits. It's essentially an industry that hasn't changed for several decades, and what we're looking to do is build a platform to allow people access to carbon credits and to sort of tokenize them to make them more accessible to people.
Hi, my name is Stradling. Entrepreneur, engineer, been involved with Bitcoin since 2011, co-founded Bitcoin.com from 2011 to 2012. I'm not associated with it anymore, just to make that clear. Since then, I've been an investor in Ethereum during the ICO, Augur, a number of ICOs since then. Most recently, I was also the inventor of Prism, which was a product that was launched by Shapeshift in May 2017.
I'm Ashley Fox. I'm the Conservative member of the European Parliament for the southwest of England and Gibraltar, and I'm also chairman of the All-Party Innovation Group in the European Parliament.
I'm Tim Huegdon. I am the co-founder of a company called InstaSupply. My co-founder was on a talk earlier. And we are largely focused on supply chain finance, though I'm on this panel largely to talk about supply chain because we're exploring ways to do interesting things with the blockchain and supply chain.
Thank you. We're here to talk about the blockchain outside finance, an outside regulated industry, but I think most industries are regulated, so let's just stick to outside finance. You know, there are lots of areas we could discuss. There's a lot of social impact going on. There's what's happening in the developing world versus you know, the first world. And, you know, I thought we'd start with where government was looking at this. So actually, you know, where are we looking in terms of what the government sees as interesting? What about land registry, healthcare, universal credit? What are those services that you think are likely to be impacted in this space?
I think it's important to have a conversation about the uses of blockchain outside of financial services, because many policymakers, when they hear about blockchain, they think instantly of Bitcoin. But actually, blockchain is much more useful than that. So imagine the problem we have with universal credit at the moment. A good system in principle, but in practice, many claimants are denied the money they're entitled to because of access to information. So imagine if those administrating that system had access to tax records and health records and could view it. And the client could view that as well and could know when mistakes had been made. Now, this is a long way in the future, but you can do the same with healthcare records. You could do the same with land registry records. There is enormous potential, I think, for efficiencies and to make life better for our citizens.
Does anyone have anything to add to that, or you know, in terms of where we're going? You know, what happens if you know, the data is made available to a lot of people? What happens if the data gets put in incorrectly into the system? What happens if you want to remove data from the system? How is that going to impact? And user control of data. You know, how do we see that impacting this area?
Sorry, me or?
Sorry, I'm throwing that open to anybody.
You're asking someone else.
Okay, well, I'll throw it over to Max.
Well, I think the issue is around whether people, if you give them access and the control of their own data, how they will use it properly. And it's a case of people have a lot of information available and whether they actually have the time and the capabilities to analyze that. I think if you're giving them their healthcare records, a lot of that information is fairly specific around what information a doctor would find useful, and it's very difficult for people to actually understand when they are giving that information and what other people need to do. So I think it's probably about trying to solve a problem for people that they can actually pass that information along to the relevant people in a simple and efficient manner. And I think there's a degree of education that will probably need to go around so that people can understand that if they have access and all of their information, how to use it effectively.
Tim, we were sort of talking earlier about sort of GDPR and privacy, et cetera. How do we, you know, the impact on those, on what we're potentially doing is enormous.
Yeah, I mean, essentially everyone wants their data to be private. I think the interesting thing about talking about getting this data onto the blockchain is that we have to remember the blockchain technology is, in essence, a distributed database, right? It's a database with no central controller, so to speak. And I think it's all very well and good talking about, putting data onto that database, but in order for it to be correct, it needs to be validated in the process of getting it onto the database. So I think there are ramifications to do with GDPR, particularly if some of that data, for some reason, is incorrect at the point that it's put onto the database. We talk about the immutability of the blockchain, and how do you then go through a process of correcting that data over time?
Yeah, and I think generally a technology stack will emerge that a lot of these applications will plug into. So now you see a lot of different startups or ICOs going along each different vertical, each with kind of their own technology stack. But ideally, a lot of the challenges that still exist to getting there, which is one, validating input data, privacy, the speed of the database. So of course, for certain applications, blockchains, distributed networks are very slow. That's what excites me most. So things like distributed storage, because you're going to have to keep a lot of this data off-chain and bring it on-chain to do compute on it. Privacy crypto, things like zero-knowledge proofs, ring signatures. One of the challenges with that is that these are going to slow your system even more. So if we look at Bitcoin or most of the cryptocurrencies and most of the blockchains in existence today, they're already very, very slow, which isn't good for certain applications. If you start adding privacy crypto, this is a segment of cryptography that allows you to run computations on data while it stays encrypted, which is fundamental to maintaining privacy, but still being able to run computations. You get even much, much slower. So building this stack that allows you to do things that are what I call high logic and low latency, it's definitely a bit far out. But it's also exciting because that tech stack will emerge, and then people will be able to link in for a lot of non-financial applications.
And do you think we're going to be left in the world where, it's impossible to remove this data, we just have to obscure it? Or do you think that we're going to find mechanisms for, we know that if you write a record, you can write a reversing record, but that might not always be good enough. Where do we think that's going? Are we going to find mechanisms for deleting data, or are we going to have to just obscure it? Adam?
Well, I mean, privacy crypto essentially tries to obscure the data through mathematical means so that you can still, again, run a computation. So that would be obscuring, but deleting essentially is the whole point of blockchain is that it's immutable, it's append only, and you're really never ever deleting data from the chain. But that again, creates a problem because, again, privacy, we were talking about some credit applications. So like in the US, you get a clean slate after 7 years if you have bad credit. If your entire credit history was written to the blockchain and you identified that, then would credit companies start skewing their results based on that, right? So this is where the privacy crypto comes in, because they could share the information or someone could run a computation on it, like a credit score, but they wouldn't be able to track maybe your history from 7 years before, and that would be up to you to do that.
Actually,
I think it's interesting how blockchain is going to interact with the GDPR law, where citizens are going to have the right for certain information to be forgotten. And I don't think we've yet confronted how that is going to take place, because the information is going to be there. So companies that run a database on blockchain, store information there, they're going to have a method of obscuring certain information for certain people, and that's going to be a complex issue for them to resolve.
So we were also talking earlier about, following from what Alan was saying, it's insurance, and someone mentioned driverless cars and the provenance of those sort of things. I think that follows on very well from that. Is the blockchain, how is the blockchain going to impact, insurance? How is it going to impact, provenance? Adding all those things we've been discussing, which are errors, being able to go back into deep history to look what's going on.
I think it's really important, particularly for driverless cars. These all have enough sensing and capabilities that should an accident occur, you want that immutable record as evidence of what has transpired in whatever event. It's going to be very relevant because it's going to be difficult to insure driverless cars, because ultimately, who is insurable? So you're going to have to use that information to make a judgment call, and that's why that record is very essential for a lot of the Internet of Things sort of technologies that are coming out.
Tim, and we were talking earlier about supply chains and the impact on supply chains and all these things coming into that.
Yeah, I think it's an interesting. Actually, the driverless cars thing is quite interesting. I think a lot of use cases of blockchain. There is always an argument like, why do you need to use blockchain? I get asked that all the time, and I think there are arguments. There are no arguments. You could be using current technology. You could use a standard centralized database for storing all that information, and everything would be, hunky-dory. But essentially, you still need to get everyone to use that database, and you've still got all the same problems of trying to get them to put all the data onto that database, so on and so forth. I think for supply chain, what's quite interesting is my company deal with customers that they onboard their accounts payable with us. So essentially, they onboard probably 100 suppliers each time, and for each supplier we onboard, there's potentially thousands of customers. So we're building this huge network of business, a business-to-business network, and a lot of our users would love to know kind of the provenance of all the products that they've got through that supply chain. I think there is because blockchain is essentially something of a time, like a time series database. It's quite useful for storing that information. Unfortunately, I think right now there's fundamentally a storage problem, because if you try and store a lot of data on a blockchain, you're immediately increasing the compute cost, right? So something that Adam and I were talking about earlier on. I think you essentially then are in a space where you have to hash that data so that it's a small hashed string that you save on the blockchain, and that refers back to some centralized database that stores that data. And then you're in the world where you haven't decentralized at all. So we're exploring where we can use proper decentralized databases to store information that's relevant to the supply chain, but not necessarily like all invoice data or all credit data, etc.
Yeah, Adam, earlier you and Tim were talking about the impact of the decentralization. If everyone owns their own data, everyone has access to their own data. That data can't be accessed by people that need to do macro management of things. How are we going to end up there?
Yeah, I mean, there's a lot of talk about people owning their own data and how you do this on the blockchain. You definitely see a lot of challenges to that still. For instance, if somebody still shares that data it gets decrypted. That data could be copied by somebody else, and there's other copies out there. Again, how do you run a meaningful computation on that data? So there's a bit of balance. I'm an engineer, so I kind of look at this. Ethereum does this because it does the computations on chain. So whatever logic you're trying to run, it does that there. But we know from Ethereum that if you have too complicated contracts, then they're insecure. And if they're insecure and it's not a trustless environment, again, why are you using a blockchain? Then you have, on the other side of the spectrum is how do people, there's a whole group that are basically, again, just taking hashes of data and putting it on the blockchain for this provenance aspect. But then again, how do you validate the data coming in, right? So how do you know the data is true when it gets hashed and put on the blockchain? It represents the proper state. And then how do you represent state changes of that data, over time? So yeah, it depends on the application, depends on how you're using it. You got to think through, when is this cost of trust so high that we want to move to a decentralized environment and it benefits our customers? Or when can we make this a smart contract that's secure? Because that's what Ethereum essentially does, is all the computers run, on chain. So it's a balance right now that we're going through.
I think another thing that's quite interesting about that is that when you talk about public blockchains, people think that all that information is completely public, right? It's in their plain text, you can go on and read it. That's not necessarily true, right? So I think ultimately, when I talk to a lot of my friends that are ethical hackers, they're in that kind of space where they're entirely cynical about data privacy. They talk about blockchain in a very positive way, and they say that we're essentially putting a lot of data onto that blockchain. That the more we can store on there, the better. Making it public and open is a good thing. But that's generally because they believe that data privacy is a myth, and there are arguments for that case, I think.
I think,
sorry.
I think part of what we need to look at is the accuracy of the data that is being added. And I think it's very simple to say that you can add data to the blockchain, but if there has to be a sort of degree of authenticity around that information, and it's whether you allow someone to say that that data at the starting point is accurate, because you'll get a lot of information through your supply chains, and you won't know whether it is actually correct. And that is part of the problem that needs to be solved before you put information on a ledger that is essentially immutable.
I think there are attempts to solve that, though, right? You can cryptographically sign a piece of data to say, I validate that data, but I mean...
But that person, again...
Yeah, you could be dishonest, right?
Yeah, you're trusting that person.
So actually, on the, moving on from that, if people can own their own data, there's all this debate in the media and within government at the moment about privacy, with the authenticity of data. Bitcoin has a reputation, as does blockchain, as does privacy at the moment. How are we going to move these sort of technologies into to deliver government services, for instance, if people are nervous about the underlying technology?
I think it's a question of trust. You need to move in small steps so that people have confidence. So it would be a very bad idea to move all healthcare records onto a new system in one go, because something would go wrong, and you've mentioned the authenticity of the data. So the best way to go about this is a series of pilot projects. So you do have examples of a GP surgery, and one surgery has gone onto the blockchain. It enables people to get prescriptions. They can even pay for services with cryptocurrency. Let's do this in small steps, and I think we will see that it gains public acceptance as it is demonstrated to be useful. And I think another use that we haven't touched on is digital identification. I went to Estonia last year. They've got a national database now with all their citizens on that ID system. And for 10 years now, that system has proved itself unhackable. So given the level of public confidence, they're now moving huge amounts of data onto that system. But it's taken them 10 years to get there. And I think we'll see a similar progression in this country.
I'm not sure if we have a couple of minutes left, if there are any questions, otherwise...
We'll just bring the Slido up. We've got 5 minutes.
Have we? Okay, so it's 2 minutes. Okay. Okay, all right. Sorry, thank you. We were talking, and one of the big issues in this space is compute power, feasibility of managing all this data. What's going next? We were talking about what areas are likely to be affected immediately by, or in the near term, by the blockchain. Gaming was one we talked about earlier. I know you've got a passion for that. Everybody, what is your, if we go through the panel, what is your area that you see as the area that's most likely to have a near-term impact in this space and the blockchain is ready for?
Asset tokenization. So I think it's very important for when people transfer assets. It saves a lot of time and administrative costs that if you can do it in a very simple, efficient manner where you're comfortable with essentially there necessarily being a central arbiter, then it will be a very near-term solution and it will save a lot of time and money and resources.
I think any application that is logic light, that is low latency, so where the service can be delivered at a slow rate, where there's a high cost of trust, so Bitcoin and these other things came for financial services first, highly regulated industries for various reasons. So if your application falls on those kind of 3 spectrums, I think you have a good one. And also a global application, right? So something that people can link into globally very easily.
Ashley?
I think a really good application in the future will be as a database for land registry. We're seeing Sweden using it already, but in particular for third world countries that have inaccurate or non-existent records, this will be an innovative way of starting up a register of property rights. Once people have property rights, they can use that to borrow, to raise capital for businesses. So I think that's a really good application.
I definitely agree with what Max was saying. I think asset tokenization is by far probably the most relevant use case right now. But yeah, as a passionate gamer, I have to think that digital economies are definitely kind of the rising star in this space, right? I mean, we've got games out there, we've got people trading things in those games. It seems like the perfect background. Use a blockchain to provide the transaction backing for that.
Thank you. We've got -1 minute. What is it? Use the questions now. Oh, we can carry on. Sorry, I haven't been
The
watching
screen
the
goes
panels
blank
today, so.
when you've gone too long.
Sorry.
The screen goes blank when you've gone too long.
Okay. Well, sounds like my life.
Questions.
So
We've got questions.
we've got questions. Oh, we go. How are the blockchains future-proofing themselves around capabilities of quantum computers to ensure data protection?
They're not. As soon as you've got quantum computing, you've got the computing power to basically hash anything. So unless you're going with a quantum security solution, that's where the problem is. But you're dealing more with quantum computing now?
Yeah, it's something I've started looking into because in the long run, we'll break some of the parts of the security model without a doubt. And there are some experiments. So for instance, there's quantum resistant ledger. This is a quantum resistant blockchain. And then there's also been a number of proposals on how you could fork Bitcoin or change Bitcoin to be quantum resistant. So it is something people have started to think about, but it doesn't have a lot of pressure right now because usable quantum computers are still very new. But yeah, in the long run, it's going to be very important to understand those security aspects.
There's a very specific one there. How does InstaSupply help businesses get paid immediately instead
I'm
of...
not sure that's relevant to this
This is not an
panel.
advert.
Is it? Yeah, I think if...
She gave her name, at least.
Yeah, if you want to come and ask me that question after the panel, by all means, I'm willing to answer it. But I think we should concentrate on the questions that are more relevant to the panel.
PVIX uses zero knowledge with proof of stake.
Yeah.
Where's it gone?
It's the second one.
And is much faster than Bitcoin. Keeps moving around. Isn't it more of a consensus issue than a cryptography issue?
That seems directed to me. In this case, yes. But by and large, when you start getting into the realm of privacy crypto, whether a number of the popular methods, whether it's multi-party computing, zero-knowledge proofs, ring signatures, typically your compute time goes up, the complexity of the potential computation goes down. And then there's also other implications like things like differential privacy. So it depends on what you're actually trying to compute and how much information that could leak. So yeah, in this case, I would agree, but by and large, this is still a cryptographic scientific problem that people have been working on for quite some time. But it's ready. I think a lot of it's ready.
Time up. Thank you very much, everyone.
Yeah.
Okay, thank you very much.